At the end of this chapter, you will be able to apply the principles of conservation of mass to chemical reactions by balancing chemical equations. Hello there! Welcome to Quipper Video. Can you recall what the law of conservation of mass is? The law of conservation of mass states that matter is neither created nor destroyed during a chemical reaction. Whatever the atoms are in the beginning of the chemical reaction, they must still be there after the reaction. Atoms are just rearranged to form the products. Why do we have to remember this law? Because this law governs the concept of our topic today, balancing equations. In the previous chapter, you learned about the three fundamental laws that govern chemical reactions: law of definite proportions, law of multiple proportions, and law of conservation of mass. With the law of conservation of mass as your guiding principle in balancing equations, always remember that in a chemical reaction, all atoms in the reactants must also be present in the products, except that they are rearranged. When balancing chemical equations, you need to work on the numbers preceding each reactant and product in the reaction. These numbers are called coefficients. They represent the whole number ratio of the number of molecules involved in the reaction. Balancing equations can be overwhelming on your first try, but with lots of practice, you can master balancing equations, in that you can even do it by simply inspecting the original equation. Now, let's try to balance this equation. Follow these steps so you get a feel of how it is done. First, write the unbalanced equation on one line with space in front of each formula for a coefficient. Second, inspect the equation and count the number of atoms for each element. If there's no number in front of a formula, then the coefficient is implied to be 1. The table shows the summary of the number of atoms for each element. The number of sodium atoms and the number of hydrogen atoms are not balanced. Here is a guide. Balance any metal atoms first, followed by nonmetals, except hydrogen and oxygen. If both the number of hydrogen and oxygen atoms are not balanced, prioritize hydrogen. Balance the number of oxygen last. Going back, using the table and the guide, sodium, a metallic element, must be balanced first. So we put 2 as the coefficient of NaCl. Change the number of Na in the table. Now, by having a coefficient of 2 for NaCl, the number of Cl is also changed. Change the number of Cl in the product side of the table. However, the number of Cl is unbalanced because there is only 1 Cl in the reactant side. So, we put 2 as the coefficient of HCl. This affects the number of hydrogen atoms too. So we have to change the number of atoms of H and Cl in the reactant side of the table. Check if the numbers of atoms of each element are balanced, both in the reactant and product side. Great! We're able to balance the equation. Let's have another one. Pause this video and try to balance the equation on your own. Let's check your answer. I bet you noticed that there are no metals in this reaction. So let's start by balancing any non-metal atoms except for hydrogen and oxygen. Start with nitrogen. If you put 2 as the coefficient of NH3, you're correct. This is to balance the number of nitrogen atoms. Now, there are two atoms of nitrogen both in the reactants and products. Next, let's balance hydrogen. There are two atoms of hydrogen in the reactant side, but 6 on the product side. Obviously, we should put 3 as the coefficient of the hydrogen molecule. Check. Is the equation balanced? Very good. The equation is balanced. Is your answer correct? I hope so. Remember, practice makes perfect. Balancing chemical equations may be tough work at first, but with practice, you will be a pro in no time. I hope you learned more about chemical reactions in this unit. You can always use these concepts in the future topics that will be discussed in chemistry. Keep on practicing, and I'll see you in the next video.